So we're now in my IntelliJ project for the EX17 example project, and this is going to show some of these issues with Java stream reduce, showing the fact that you need to use correct identity values, and also you have to make sure that the operations you're applying are indeed associative. And it also will show what goes wrong when reduce performs a mutable reduction on a parallel stream. So let's go ahead and run the program. It'll run in the background. It's got a little bit of work to do. And let's take a look at the different examples. So there's a whole bunch of different examples here that we're going to look at. And what they basically do is try out a bunch of different features of streams and see which ones work and don't work with parallel streams. So here's the first one. This is the one that's going to do a bunch of difference operations in parallel. So you'll see that in this case, we're either going to run in parallel or not, and we're going to use subtraction, which is not associative. And you'll see that you get different results for the parallel versus sequential versions of these. So let's go ahead and take a look at the first results here for test difference reduce. And we ran the program, and over here you can see the results. So you can see here that the difference between these values for sequential and for parallel are quite different. And so that indicates why we should be very careful when using operations like minus when we're doing reductions in parallel. Let's take a look at another example. Here's test sum. And you can see in this particular case, we go ahead and pass in values here. So you can see that the sequential sum and the parallel sum for first 100 numbers with an identity of 0, which is correct, leads to the correct result. Whereas in contrast, when we do the sequential sum with an identity of 1, which is the wrong value, we get the wrong value and a different value. And you can also see that if we pass 1 in for the parallel sum, we get also an even more different value. But if we do it with parallel streams, it works fine. The next example is similar idea, except this time we're computing product. And in this particular case, you can see that the sequential product of the values when you pass in an identity of 1 is correct for both parallel and sequential. But for sequential, when you pass in an identity of 0, you're of course going to get a value of 0 because 0 times anything is 0. Here are the examples then with the buggy stream reduce. This is the one that's going to be using the string builder example. And you can see that when we run these things in parallel versus sequential modes, this is pretty funny. So this is the time that it uses the sequential version. That's perfectly fine. When we use the buggy parallel version, look at the output. It's just gobbledygook. And that's because this append operation is being done in multiple threads at the same time on the same non-immutable object, the string builder. And so you just get crazy, crazy, crazy results. We're actually somewhat fortunate it even worked at all. It could have very well crashed. So not a good thing. And so there's a couple of different variants here. So we have another example which does something similar, except in this case, we're going to time how much time it takes to do it, and it'll tell us how long it takes. And again, we get incorrect results when we do sequential versus parallel. When we turn around and use the version that uses string concatenation, then we get the correct results, except it takes longer. So you can see up here we record the amount of time it took to do this. So it took us very, very little time to do things incorrectly, but when we do things correctly with the string, then it's going to take a longer time to do that. And then down here we show how to do it with joining, and the joining approach is going to be correct and luckily not too inefficient relative to the approach that used strings. So that's just an example. You can run this yourself and see what it does, but it's an example that demonstrates the behavior of different reduce mechanisms or reduction mechanisms under different sets of assumptions.